Alright guys, welcome back. Today we're going to talk about similar triangles. Now here's a picture from Haese textbook. Basically you can see that if you have two shapes congruent, they have to be same shape and same size. Whereas if two things are similar, we only require same shape. The size actually doesn't matter. But just because it doesn't matter doesn't really mean that it cannot be the same, right? They can actually be exactly the same. We could have exactly the same shape, same size, and we can still call two shapes being similar. So one example is if I have two triangles like this. Are they congruent? The answer is yes. Now are they similar? The answer is also yes. Now today we're only going to focus on similarities between two triangles. For triangles, because they're so nice, we only have three sides and three angles, so the things are a lot simpler compared to, for example, these guys. Now if you have two pictures that you want to prove exactly similar, you actually have to compare every single angle, corner, laugh, teeth over here to prove that these two guys are exactly the same in shape, and therefore to prove that they are similar. But for triangles, we only need to compare angles. So it says over here, two triangles are similar if we can show that at least two of the corresponding angles being the same. Why only two? Because if you can prove, for example, 60 being the same as 60, and then you have 80 being the same as 80 over here, since we know that the third angle, just 180 minus the other two, you can for sure guarantee that the third one will be exactly the same. The other way to prove similarity is to prove that the corresponding sides are proportional. Now here's just a little note about the notation. If I say triangle ABC is similar to triangle DEF, the mathematical expression is triangle ABC with the little squiggly sign over here, which means similar to triangle DEF. So the following examples, we are going to use any of the three in order to prove similarity. You will probably see the first one being the most common one. In fact, today you'll probably see all the examples involving this one. The other two are not very common, especially the last one over here. But I just want to list it out so that you guys know there are also other different ways to prove similarity. First example, pause the video. Whenever you're ready, we will continue together. So again, we can follow any one of the three over here depending on what information we're given. It looks like we can compare the angles because, for example, we can start with angle A being exactly the same as angle A. And the reason behind that is because we have this angle shared between the big triangle ABC, and then the smaller triangle ABC, and then the bigger triangle ADE, if you break them into two. Now, second of all, you can actually claim that the ABC and ADE angles are actually exactly the same. So you can say ABC is exactly the same as ADE. And the reason behind that is because they are actually what we call corresponding angles on the two parallel lines. And we're actually done. This is actually enough for us to conclude that triangle ABC is similar to a triangle ADE. And the reason behind that is AA. So that's it. So pretty much the same format. Most of the time you have three lines of evidence, but in this case two is enough for us to prove similarity. Part B, we can start with these two angles being the same. So how about let's say ACB is the same as angle DCE. Well, it's because we have opposite angles. Second of all, we see that these two lines are parallel over here, so that's why we have this zigzag, these two zigzag angles over here being exactly the same. ABC angle equals to EDC, and the reason is alternate angles. Again, we're done. We have two angles being the same, therefore we can say triangle ABC is similar to, be careful of the order, ABC is similar to EDC. And then we also have AA. Second example over here, again pause the video, whenever you're ready we will go over together. So first of all, we have angle ACB equals to angle DCE. We have opposite angles. Second of all, we have ABC equals to DEC. Well, because it says over here on the top that both of them are 40 degrees, so we can just say it's given. And then we are done. Triangle ABC is similar to triangle DEC, AA. Second one, again we can start with the shared angles. Angle R equals to angle R. Shared. And then we notice that we have two right angles over here. You can basically just say RQS equals to RPT. It's given. Both of them are right angles. Therefore we are done. We can say triangle RQS is similar to triangle RPT, also AA. Now last one is a little bit tricky. If you actually break the two triangles down, you will see something like this. You will have the big triangle being AEC with 108 degrees over here. And you have a smaller one that's called DBC that has 100 degrees over here. Okay, so first of all, you'll compare these to 100 degrees over here. You will say angle AEC is equal to angle DBC because this is given. Okay, notice this is still a better way to say AEC instead of just saying angle E. in DBC instead of saying angle B, especially for this angle B over here, that if you just say angle B, we don't know which one you're talking about over here, so it's always better to be specific. Now again, the next thing will be the shared angles, angle C and angle C, being exactly the same. So shared, therefore we're done, we can make our statement over here. Triangle AEC is similar to triangle DBC, AA as well. So that's it for today, guys. I'll see you in the next lesson. Peace.